Hi, it's Miss Keene. I'm going to talk to you about dilations. Now, dilations are the type of transformation that does not stay congruent. Congruent meaning the same size, same shape. It is the same shape, however, it's not the same size. It can be an enlargement or a reduction, so it can shrink or get bigger. So let's see how this works. Now, you're going to have scale factors. So here's some tips for you. If you have a scale factor that's greater than 1, that means that your image is going to be getting bigger, and so your image is stretching. If your scale factor is between 0 and 1, that means your image is shrinking. It's getting smaller. Think about that. Like half the size, a third of the size, a fifth of the size would be smaller. If you have a scale factor of 1, that means the image and the pre-image are exactly the same size, same shape. They are congruent. They're not shrinking or stretching. So let's put this in action. So I have an example here. It says graph the dilated image of triangle JKL using the scale factor of 2 in 0, 0 as the center of dilation. Okay. So center of dilation, that's right there. So what is happening is this scale factor of 2 is getting twice as big. So let's see how that works. So J. So first I'm going to write the original coordinates. So J, we always start at the origin when we're talking about coordinate points. The X is going to be 2 and the Y is going to be, the units of 1. So 1, 2, 3, 4. So J is 2, 4. K is 1 on the X and 1 on the Y. And L is, I do the X first, is 4, 0. Some people get that mixed up. They write 0, 4. If you always think about your X first, think about you have to run before you can rise. The X goes first. So if you think of it as a map, you start at the middle, the home base, the origin. You have to go over 4, and then you're rising none. So it's 4, 0. All right, now a scale factor of 2. What that means is you take your coordinate points and you multiply each of those numbers by 2. So I'm going to do 2 times 2 is 4. And then 4 times 2 is 8. And I'm going to continue to multiply everything by 2. And once I have those coordinate points down, then I'm going to go back to my coordinate grid and I'm going to graph those. And 0 times 2 is 0. Okay, so I'm going to start with J. So J prime is going to be 4. I always start at the origin, go over to 4, up to 8. 1, 2, 3, 4, 5, 6, 7, 8 is going to be here. Okay, so that's J prime. Label as you go, makes it a lot easier. Let me try that again. There we go. Now I'm going to do K prime. K prime. Go over 2, up 2. And it's okay that your shapes overlap, because we're getting twice as big from that origin. And then L prime is going to be at 8, 0. So I'm going to go 8 and 0. Then I'm going to take a ruler or a straight edge and connect the points. Okay. and that is a dilation of 2. So what I've done is I've taken that triangle, JKL, the original pre-image, and now it's twice as big. And that is represented by J prime, K prime, and L prime. Let's see an example when your image shrinks and gets smaller. So M, point M is 4, 5, 6, 7, 8, 9. Okay, there's 9. I just didn't know how many. Okay, so we'll do point M first. So I always do my X over 3, up 9. So point M is 3, 9. Do the same thing with N. Point N is 6, 0. Point O is 3, 1, 2, 3, 4, 5, negative 6. Point P is negative 3, 0. Okay, now I have my original points, my pre-image points. Now graph the dilated image of quadrilateral MNOP using a scale factor of 1/3 in the origin as the center of dilation. So this shape is going to get 1/3 the size of the original shape here. Okay. So what I'm going to do is I'm going to take each of these numbers and I'm going to multiply them by 1/3. Now, when you multiply by 1/3, you can use a calculator to do that. Lots of people ask me how to multiply using on a calculator. I find that the easiest thing to do is, like, for example, if I'm going to multiply that 3 times 1/3 in a calculator, I would input 3 times, and then I always put my fractions in parentheses. That way you do not get messed up on order of operation, and it knows, your calculator knows that you want that 1/3 to belong together. I'll show you what it looks like on a calculator. I don't know if you can see that. There we go. So I have 3 times, and then in parentheses, let me try that again. There we go. There we go. 3 times 1 divided by 3. A fraction is just division. People get afraid of fractions, but it's just division. Now, I'll give you an alternative. So that'll work in your calculator. Absolutely. If you want to do it by hand, when you multiply fractions, you just multiply straight across. So you multiply your numerators, you multiply your denominators, and then you simplify. 3 times 1 is 3. 1 times 3 is 3. And then simplify it. So that's 1. Okay. Another option is multiplying by 1/3 is the same as dividing by its reciprocal. Reciprocal is just another word for taking your fraction and flipping it upside down. So multiplying by 1/3 is the same as dividing by 3. It's true. 3 divided by 3 will give you the same answer. Whichever you find easiest, multiplying by 1/3, either on a calculator or by hand, or just dividing all your numbers by 3, get the same answer. So I am going to put the new coordinates here. So that's going to be 1, 3. For me, I find it easiest, instead of multiplying by 1/3, to divide by 3. So that is what I'm doing. Now, -3 divided by 3 is -1. You got to be careful of your signs here. You got to know your positives and negatives. And that's a funny looking 0, but that's going to be 0. All right. Now I'm going to plot my new image. So I'm going to go from the origin over to +1 up to +3. That is M prime. I label as I go. Go over to 2 and then 0. That's N prime. O is +1 down to -2, and that's O prime. P is over to -1 and then up 0, so it's just on the x-axis. That's P prime. Then I take a ruler or a straight edge and I connect my points. And when I do that, you get the same image. It's just shrunken down. It's just smaller now. It's 1/3 of the size. So that's an example of when you have a scale factor bigger than 1 in your example, your image gets enlarged. And this is an example of when your scale factor is between 0 and 1 and your image is shrunk. Thank you.